So we continue with the operation between vectors, and particular for this section is a section, I think this is a section to 6.2, and these are for vector addition and subtraction. I think for coordinate-wise operation, we already know. Uh, then we just need to get familiar with how to visualize it. I think before we also have a so if A, B are in this direction, and then we have A plus B looking like this. All right, but this is really if we move A parallel to here, and then this become like a cycle, right? So we starting from, so whether it's A plus B or B plus A, we always arrive at the same ending. So starting from the origin here, and then we travel B distance and then A, right? So summation or addition of vectors is actually, we just travel along the arrow, is as simple as that, right? So if starting out A and B, it look like this, you don't know or you forgot what is A plus B, you can move one of the vector in parallel to here, right? So then A plus B just become, so yeah, we just travel along the arrow, like the head of the arrow is the end, meets the end of the other vector, okay? And then this become A plus B, okay? And then A minus B, the same thing, we travel is only, we use this minus B, and then you can draw a minus B with the opposite direction, and then we travel along those vectors, okay? And polygon rule, I think there's nothing much to remember, but you just be familiar with this language. Is called a resultant, which is the sum of n geometric vectors. Yeah, so the next vector with its tail on the tip or head of the previous vector, and the sum, or is called the resultant of a vector that is a tail at the tail of the with the tail at the tail of the first vector and the head at the head of the last vector. Okay. Um yeah, so we're basically connecting the head with toe. Yeah, I think it was okay. It's only this word, because later we're going to I think there's something called resultant force, uh, and in physics, if we draw them down, it's just summing up like different forces and then see the overall resultant force. Okay, yeah, I think this is very intuitive. And then okay, the following diagram, yeah, I think it's fine. We just keep drawing this, like A plus B is here. Okay, yeah, we just piece them together. I think these are fine. And the following diagram and triangle rules, we just keep traveling, right? So A here, and then B travel to here, and then C we further travel down to here. Okay, A, B, C. Yeah, I think we're fine here. um Parallel rule. Okay, parallelogram rule. Okay, so this is another, yeah, you probably have seen this. This is another way of calculating vectors A, summing or add B. If we have two vector position like this, like previously I said, if you forgot how to draw A plus B, you can move the A vector parallel to here, move it to here, and then you just travel from here, and then this arrow, and then another arrow, you travel from the to the destination. right? But in a parallelogram, um, like but this needs to be careful. Like, don't just remember the rules. Like, don't just remember it like the dry rules, right? Because this AB, like the arrow is going out, and then this is A plus B, right? But what if it's like here and here? Then it's different, right? Yeah, it's yeah. So don't just remember recite these rules, okay? Because math is very flexible. So be careful with what you remember. Um, yeah, I think as long as you remember how to adding up vectors, I think it's fine. And then A plus B, I think you can still like the head of the arrow is a tail of another vector. I think it's fine. Yeah, I think there's not much to worry about. Okay, so this is what we like. I think we mentioned this for one example here, right? Um, so we have a relation between the angles and the sides is that given a triangle with the angles big A, capital B, and capital C, we take these angles and then take their sine, take these angles and take their sine, uh, and then their sides A, B, and C, right? So we just need to notice the coordination. We just need to know the correspondence. The side little a corresponding to the angle A that is opposite to the side, right? So this pair, like sine A over A, okay, and then sine capital angle B over this side B, okay, and then the sine capital angle C over this side C, okay, and yeah, there's something called the cosine law on the right. Yeah, I don't know if you have heard of it. So for a square, this a side, and also its corresponding angle would be the angle that's opposite to the side A. So the angle capital A is b squared plus c squared minus 2bc. Okay, and then you can also compute it. Okay, so another formula is that you can also compute the cosine A from actually this formula is that b squared plus c squared and then minus a squared over 2bc. Yeah, and then in this way we calculate the cosine A. Okay, so we'll skip the proof for now. I think this one sine law is more commonly used. Yeah, but we can take this. Yeah, just remember like this angle corresponding to the angle that's opposite to the side A, right? Yeah, and as long as we can remember like one of this formula, and then we can also be able to apply others. Let's see about this magnitude and directions for the vector sum. So this be the angle between vectors A and B when they are placed tail to tail. Okay, yeah, just a notation theta. And the magnitude of the vector sum is given by, yeah, because we have the, remember we have the pi we have the Pythagorean rule, right? So for Pythagorean, for right triangles. So how to relate this? Last time we talked about the Pythagorean rule. If we have the A is 90 degree, and then the little a is the side that's opposite to angle A, and then the length we have the Pythagorean rule is okay. I'll just dot. Pythagorean rule is a squared is b squared plus c squared, right? Remember that we just talked about it in the last video, right? And then this is for the right triangle, but then these are for general triangles, right? Yeah, these are for right triangle. Oh. Yeah, and then these are for general triangles, okay? And then general triangle is just still like a squared is equal to b squared plus c squared, but also minus a 2bc cosine a. Okay, and for now we skip the proof. General triangle. Okay, and as you can see, when we have the right triangle, the cosine 90 degree is equal to 0, right? Right? Cosine 90 degree is 0, so that when we have the right triangle, we still have this formula, but applying when A is a, a right angle 90 degrees, so this term disappear, okay? Yeah. All right. The magnitude of the vector sum is given by this is the same formula as above, right? Cause I think you know. Um, yeah, this is yeah. You don't have to remember everything. You just remember maybe this. I think it's fine, right? Cause these ones, if you understand one of the above section, and then these ones you can just freestyle. You can just deduce it yourself, because you already understand how these working, right? So this is A side, B side, and then A plus B. Yeah. Also, also depend on how you drew the vector. Okay. So, but if you drew in this way, A this arrow, B this arrow, and then A plus B this arrow, and then yeah, and then of course the other side will be this side plus this side minus 2ab cosine gamma, and then gamma is yeah, as long as you understand the how this formula work, that we talk about how this work, and then you just apply this, just change a little bit, right? This gamma would be again the angle that's across from the side A plus B, right? So gamma would be here, would be the angle that's across from A plus B, right? And then you just freestyle deduce by whatever means that's convenient to you. Just write it in your own way. You'll be great. You're doing great. And by the definition on the bottom G section, because it's saying that it's nothing but it's just telling you a story that this angle means theta, and then this one means theta, and then gamma is just this side. Yeah, so it's just a matter of storytelling. I think you guys are very smart to deal with it. And again, for this sine formula, sine law is still the opposite side and over the sine or of the corresponding opposite angle, right? And then AB and AB A and B, alpha beta depend on how you define it, right? Yeah. And apparently alpha, yeah, I think alpha means here, right? Yeah, I think these are fine. Okay, so analyze the following specific cases of addition of two vectors. Yeah, okay, is so if their theta is 0 and then it's of the same direction, right? So A and B. Yeah, so that's what I mean. Like these later section would be much easier, right? So if their theta 0 means the same direction, not only parallel but also same direction, okay? And then A plus B is just something longer, plus their length, right? Yeah, I think you guys can do it better than me. And right triangle, again, Pythagoras, right? For the other side, yeah, this question is not even well stated because it's not telling like what's gonna do. But anyway, okay, then this theta is pi. It means opposite direction. Okay, A and B, and then A plus B. Then here is look like something like this, right? And the length, the magnitude is a difference of their length. Okay, the pi just means their angle is pi 180 degrees. They're in opposite direction, right? And example 5, given the magnitude of two vectors, the angle between them when placed tail to tail, okay. See this wording, tail to tail, and being 60 degree. And then find the magnitude of the vector sum and the direction magnitude of the vector sum and the direction, okay, angles between the vector sum and each vector. All right, so because it already tell you that the position of A and B is tail to tail, yeah, so we don't move it parallel, but but the direction, oh, sorry. Oh, well, you can still move the vector B. I think it's all right. So A plus B is here, and then B is here. Let me see. And then what do we do? Yeah, to calculate, let's see. I think this question somehow. Okay, so again, it's the same trick, right? So this and cause I it's the same trick as this here, right? Okay, so it seems like it's asking a question according to this rule here. It's exactly the same picture here, right? Because I move B parallel to here. Oh, Oh. So this angle here will be the same as 60-degree, right? Again, we want to construct some triangle and then learn the magnitude of a plus b, right? Yeah. Again, we want to do that. And yeah, and then this angle would be 120, right? Yeah. And then this is so that we can draw again the triangle. You should draw draw it on yourself, right? Okay, so this is A, and this is B. So if I were to add this in the example of midterm or final, you should know, right? And then this is, you just draw this triangle again, and then our goal is to calculate this a plus b here, right? And then because a plus b, we care about this 120 degrees because it's the opposite angle of a plus b, right? And then you just calculate the, and don't forget, just like our Pythagorean rule, we use a square. If you just remember that if you don't have a square root in your formula, you definitely have a square of your sides. So square a plus b is so write out the Pythagorean rule first, a squared plus b squared, and then minus 2ab, and then I think the formula call this gamma, right? Cosine gamma, right? Yeah, I think it's just plugging in the formula is much easier, right? Much easier than the problem that we learned before. So yeah, it will be easy breezy. Okay. Yeah, just understand how to calculate this gamma here. Okay, and this is opposite angle here, and then we can get it from the angle here. Okay. All right. Let's see. Example 6 is given a, b, and then a plus b. Find the angle between vectors a and b. It's the same formula, isn't it? Yeah, it's the same formula. And again, you see, like it's saying like theta is AB, so what it's saying like is drawing A and B again, theta, and then A plus B is this line in the middle drawing out, right? So you should be comfortable with this process. And then it's asking the angle. Oh, sorry. What is this asking? Find the angle between vectors A and B. Yeah. Find the angle between A and B. And again, we have A plus B, this length, A plus B, and we want to use it, right? Of course, we want to use it because it's given as a condition. And so, gamma is here. This is gamma, and then this is our theta, right? Sorry. And then this is our theta, right? Yeah. I think as long as we know gamma, we know theta, right? Because gamma plus theta is 180 degree, right? And how do we know gamma? Well, because we have this triangle constructed, right? So a plus b, gamma, a, b, and then so because we have that, again have that formula, we can calculate gamma, right? Because again, it's sorry, I'm just very lazy. But you should be able to write down the formula yourself. Right, so write down the formula yourself and see if you agree with me, right? Because I might make a mistake. You should know. So for this formula, we know a plus b this length, we know a length, we know b length, and then these two we know, and then so cosine gamma we have, right? And then gamma is just you just write cosine gamma is blah blah blah, and then gamma is arc cosine whatever value you calculated for cosine cosine gamma, right? Because arc cosine is the inverse function of cosine, right? So as long as you calculated what is cosine, and then you get gamma cosine, as long as you have cosine gamma, and then you are able to calculate gamma, right? And then vector subtraction. This okay. So this is again, if you have like two vectors, position in this way, a and b, and then what about b? A minus b is, yeah, like actually I think I also liked it in a way. If you're going to brute force, remember this, a minus b. So if provided that a and b is positioned like outward, okay, outward arrow look like this, outward, and then if you gonna brute force, remember direction of a minus b is going to be starting from a and then toward b, okay? Yeah, I think so. Is it wait, I forgot, I even forgot this. Okay, a minus b is, okay, the direction is toward the vector that's being subtracted, I think. Look like this. Yeah, but yeah, but what you can do is that you can always move b around. You can still a look like this, right? Red going up, and then b is subtract a b. So b is the other direction, other arrow. Look at minus b, right? And so it's a plus minus b, right? A plus minus b, then it look like this. It's like the diagonal of the parallelogram of a and minus b. Okay, so this is a plus minus b. Yeah, I think don't you don't need to, up to you if you want to remember anything, but I think as long as you remember how to add two vector, and then you just let one of the vector be opposite direction, and I think you should be fine. Yeah, and then yeah, I think I'll skip this, and then let's see inverse operation. Vector subtraction operation is the inverse of operation of inverse operation of the vector addition. Yeah, of course. Okay. D is a minus b. A is b plus d. Okay. Let's see. Okay. So D is a, yeah, see here, D is a minus b here, right? But you can also write out here is a, you can a vector travel from here to here, and then you can also, another way to a travel from, let's say O to P, you can also travel by going B and then going this direction, right? So this is like OP is also is equal to A is also equal to B plus D, right? So addition vector is just tail to tail, you just travel along it, right? This is actually a very important concept. Not actually like inverse operation, but just adding vectors is like traveling along the vectors, okay? Traveling along different vectors. And then there are different paths to from definition to from the starting point to destination. And this is actually important application to later question, okay? And then magnitude and direction for vector difference. A, B are two vectors, and this be the vector difference. Theta be the angle between vectors A and B. And the magnitude is given by, yeah, is okay, A minus B. Yeah, as long as the thing is, again, you draw this triangle, right? You draw where is the side A minus B, right? Where is the side A minus B, and where the side A minus B, and then theta will be the angle that's opposite to the side of A minus B, right? And yeah, so this is the same formula as above, as here, right? So it's just we'll pick a side, and also the angle is the opposite angle, like opposite to the side, okay? Yeah, so it's the same, but yeah, it's only an application of the previous formula, right? And then the only difference, you don't need to remember this formula, just like draw A and B, and then where is A minus B this side, and then you you just apply the previous formula, and then you're fine. Yeah, so you don't need to remember everything. Okay. And we still have these, I think. Let me think if I want to yeah, let me see if I want to give some of these as an exam. But I'm not sure. Okay, let's see this example 8. Given a magnitude of two vectors A and B, and the angle between them placed tail to tail. Okay, tail to tail. Well, this looks like tail to tail, right? The arrow is always outward. A and B. And then find the magnitude of the vector A minus B. And then where is A minus B? You can, or of course, A minus B, and then draw. Yeah, I think it's safe to do it. Just draw minus B. Okay, and then minus B, and then what is A minus B? A minus B just look like this, right? The A plus minus B, right? Look like this. Yeah, I think it's safe to draw in this way. Here, minus B. Okay, I find the magnitude of the vector. Okay, sorry, I shouldn't draw it like as if it's a right triangle, but the angle, sorry, the angle is like 120. Yeah. Yeah, so here is negative B, okay. And this is A plus negative B. Yeah, sorry, this look a little bit ugly here. But I think you know what I mean. This is A plus negative B here. Alright. So draw the difference vector D. This is D, and the direction, and draw a diagram. Yeah, I think this is a diagram, and the magnitude of the vector and the direction and the magnitude would be yeah, because this is the angle 120. Yeah, you can also draw in your own way, right? Because if you don't like my way of doing things, you can directly draw this is a minus b. You can directly draw this, okay? All right, and then a minus, again, we use that formula, not necessarily this one. You just remember the previous one, you're fine, right? Just remember this, the opposite angle, and then this side, we don't calculate a side square is b squared plus c squared minus 2bc cosine the opposite angle. So I think we're fine here. So to calculate a minus b squared, so you should write it down, not just watch me do this. And minus 2ab, yeah, cosine 120. And I think you're fine, okay? And let's stop for now.